Hi, my name is Krzysztof Cwalina. I'm a program manager on the Common Language Runtime team, and I will be talking today about new Common Language Runtime feature called generics and some of the common APIs that we are adding to the base class libraries. So let's go to the whiteboard and talk about some basics of the feature. Some of the common scenarios for using generics is to create strongly typed collections. You can see in V1 and V1.1 of the framework, we didn't have generics, and we created some collections that are typed as object. And they have several problems that I would demonstrate now on the board. So let's, for example, use a stack collection and store two integers in the collection. So I instantiate a new stack. I push two numbers, 1 and 2, into the stack. That looks all pretty good. But now when I retrieve an integer from the stack using the pop method, the method is typed, the return value of the method is typed as object. So since I stored integers, I want to get integers back, I need to cast the return value to an integer. That has some performance overhead, and also it has the API has some usability problems. You can imagine getting a stack from somebody, some API, and trying to pop a value from the stack. It will be typed as object. You need to know what the actual type of the item stored in the stack is. So now let's see how stack pop method is declared in the framework. So class stack has a public method that returns an object, and it's called pub. And of course, it has some other methods. Now, this part is where that's the root of the problem. In the WIDB time frame, since we have generics, we are adding several collections that take advantage of the feature of generics. So we created a new stack or new set of collections in system collections.generics namespace. Each of these collections have additional type parameter. Type parameter specifies the type of the item that is stored in the stack. Now every single method that retrieves or manipulates in any way the item stored in the collection can be typed as T. T represents a type of the item stored in the collection. Now usage of this class will be very similar to the usage of the non-generic stack, except all APIs are strongly typed, you avoid casting, performance overhead, and so on and so on. So let's see how stack of T can be used in your applications. You would declare stack of T to store integers by just adding bracket and integer to indicate this is a stack of integer. You have to do this here as well. Push method really doesn't change, except IntelliSense now shows you that the object passed to the method has to be typed as integer. So 1 and 2 are integers, everything compiles fine. Now, as I mentioned, pop method is typed as T. Since T is an integer, pop method will return an integer, so the cast is not required. So this is a very simple scenario showing how generics can turn a loosely typed API into very strongly typed API, improving performance, usability, IntelliSense experience. So let's take a look at some of the most important APIs in the system collections.generics namespace. In the namespace, you will find IEnumerable of T, that is an interface very similar to IEnumerable interface. It represents a sequence of items, and the items are typed as T, which is to the contrary of IEnumerable, which is untyped typed as object. IEnumerable is a base class for, or base interface of iCollection of T interface. iCollection of T is more different from iCollection interface that you know from V1 of the framework. We added some mutators to iCollection of T, like add, remove, all the methods known from iList interface, except the ones that use the concept of an index. So the next interface in the inheritance hierarchy is iList of T. iList of T, as I mentioned, adds the concept of an indexer. Second interface that inherits from iCollection is called iDictionary of KV. That's dictionary of key value pairs. And then we have two concrete types that basically implement those core interfaces. List of T is a workhorse of the framework. It's a basic collection very similar to array list. And dictionary, KV, is a collection very similar to hash table. Now let's talk about some of the differences between these two collections and collections from the V1 of the framework. Main differences will be found in the dictionary and hash table pair. So as you know, for example, dictionary returns null value if the key is not found in the collection when you try to retrieve an item by a key. We could not do it in the generic collection, generic dictionary. The reason for it is that V may be a value type, and value types don't actually have null values. So we couldn't return null from the indexer retrieving a value from a dictionary. So you will find several members that retrieve items from a dictionary, and they are designed for slightly different scenarios. In some scenarios, you would like to avoid exceptions when the key is not found. In some scenarios, you would like to specify the default. If the key is not found, then the default value will be returned. Some other differences are implementation specific. So hash table and dictionary are slightly differently implemented. They will have slightly different performance characteristics. List of T, again, it was optimized as I said, as the workhorse of the .NET framework. It will be very performance. We improved the enumeration of list of T versus enumeration of array very significantly. There are also some of the supporting types. I talked about stack of T, and queue of T. They are very similar to the non-generic collections known to the users of V1 of the framework. So these are the interfaces and the concrete types that you would usually use in implementation of your application. Now, the namespace will also contain some types that can be used in object models. So let's look at these. There's a generic collection called collection of T that is intended to be inherited from and returned from object models. So you can imagine a directory class that has a property files that returns a collection of all files that are found in the directory. API designers would use this collection of T as the return value of the property. The reason for it is that list of T is not intended to be inherited from. It's not sealed, you can inherit from it, but you actually cannot override any members. All members are non-virtual, and that was done for performance reasons. Non-virtual members can be inlined, there's no indirection, and so on and so on. Collection of T, on the other hand, has many members that can be overwritten, and you can, for example, get notifications when something changes in the collection, gets added or removed. Another base class that was added to the framework is called read-only collection of T. This was added as a response to many requests that we got from customers, from you, for a collection that is a truly read-only collection. The collection has only read-only APIs. So, for example, you will not find public method add on the collection. You will not find remove. But again, it's intended to be inherited from and returned from object models. Another collection, again, intended for inheritance, is called kit collection. Kit collection of T. Kit collection is very similar to collection known to VB users, the VB6 collection. It's a collection of items that can be indexed both by an integer, like regular collection, and a key. Key can be, actually it's kit collection of KT, because key is also a type parameter. Key can be of any type. Usually key would be a string. So you can imagine, again, a collection of files in a directory where the key would be the file name of each file. How does it differ from dictionary? As you can notice, dictionary doesn't actually implement iList interface. It shouldn't be viewed as a sequence, ordered sequence of items. It's rather a mapping from a key to a value. Kit collection is just an ordered list of items that happen to have some keys associated with them. And of course, I talked about briefly stack and queue, stack of T and queue of T. These are very similar types to the ones that we have in the V1 of the framework. Another new type that we added, and that was again very common request from our customers, is linked list. So you will find a linked list type, and I think it extends iCollection of T. Linked list is basically a collection optimized for additions in the middle of the list, at the beginning of the list. Operations that are very inefficient with list of T, collection of T, and all these other collections. And I think that sums up the most important types in the namespace. But they are not the only generic types that you should be aware of. As I said, there will be many, many different types using the feature, the generics. Collections is one group that will be very common, but there are also other types that will be common, and you should be aware of them. So let's briefly talk about them. As you probably noticed, .NET Framework has many delegates called something event handler. They are intended to be used in events. The only difference between those event handlers is that the second parameter to the handler is different subclass of event args, system.eventArgs class. This is a perfect example where generics can help in uniformity and can save some development type. So we created event handler of T. And basically, event handler of T is just like any event handler. Of course, the first parameter of the event handler is object sender, and then historically, the second parameter would be manually specified, and that would be one of the subclasses of event args. In the generic event handler example, the second parameter is just t. So now you can see you can create new event handlers by simply supplying the event args subclass as the type argument. This is an important type, and you should take a look at it. Another important type is called nullable of t, and I think in the PDC builds it was called optional value of t. There's an issue with value types not having null values, and sometimes developers actually need to extract some information, let's say from a database, and databases usually have nullable integers, nullable types that are mapped to value types in the .NET framework. And nullable of t actually helps in solving this problem. So let's see how nullable of t would be used. You can declare nullable of int I, and it creates an integer-like type that actually can have a null value. So you can assign null to the type. And actually here compilers this is a structure, this is a value type. So without the compiler support, this statement would be illegal. Not valid. But compiler actually generates an instance of nullable of int and sets its internal Boolean property is called has value to false, meaning it doesn't have a value. It's a null integer. So you can see a statement like this. Console I has value would print a value of false. Now you can assign an actual integer, let's say 5, to I, and the compiler will generate an instance of nullable of int with has value being true and the value property being 5. So now the output from this short snippet would be has value true and the value equals 5. So as you can see, we created a type that is a wrapper over value types. It can be also used over reference types, but the common usage is over value types. And it adds additional Boolean to those value types, and the Boolean says, hey, am I null or not? You will see more and more usages of this type across the framework. It's a very common pattern, and it's a very useful class. So as you can see, generics is a very powerful feature. You will see more and more APIs taking advantage of the feature. It will start with WIDB. We will have generic collections, some supporting types like nullable of t that we talked about, an event handler of t. In the long-term time frame, you will see more and more APIs taking advantage of generics. I hope this is very exciting. WinFX will be one of the first operating systems with truly object-oriented APIs, and it will be probably the first operating system with APIs taking full advantage of parametric polymorphism. Thank you very much.